Welcome to the Deep Dive. Today we're getting into something, well, pretty relevant if you've ever worked out. Why some activewear keeps you feeling good and dry, while other stuff, not so much.
Right. It can feel like you're swimming sometimes.
Exactly. We've got some really interesting research here, and our mission basically is to unpack the science behind quick-drying sportswear. We want to figure out why it matters for your comfort, maybe even your performance, whether you're a serious athlete or just value feeling comfortable. We've looked at the studies, so yeah, expect some cool insights.
Absolutely. We're aiming to go past the usual marketing claims and really understand the science, how fabrics actually handle moisture. It's all about that interaction between your body, your sweat, and your clothes.
And just to kick things off, here's a fact that really made me think. During really intense activity, your body can actually produce over 800 milliliters of sweat in just an hour.
Wow. Yeah, that's nearly a whole liter.
Right. Suddenly that quick dry feature seems less like a nice to have and more essential.
Yeah.
So to help us dig into the fabric science, we've got our expert here.
Happy to be here. Yeah, when you're talking about that much moisture, how well your gear keeps you dry isn't just about the material itself. It's also tied into how sportswear design has actually changed over the years.
Okay, let's talk about that evolution. Because sportswear wasn't always this, super technical gear we have now. Our sources mentioned that back in the early 1900s, things started shifting towards more practical designs for sports. But the really big leaps in terms of fashion and, more importantly, fabric technology have happened mostly in the last, 50 years or so.
That's right. And a huge part of that innovation, especially for the clothes you wear right next to your skin, has been solving the sweat problem. That damp, sticky feeling isn't just uncomfortable. It can genuinely mess with your body's temperature control.
Which could affect how well you perform.
Definitely. It impacts thermal comfort.
And just to be clear, when we say sportswear, we're including everything from high-performance gear for athletes to that athleisure wear that's become so popular.
Yeah, the comfy stuff you might wear to the gym or just out and about.
Exactly.
Yeah.
The point is, if you're moving in it, how fast it dries is really key for comfort because it needs to get that sweat off you.
Right. And to really grasp the challenge, think about sweat volumes. At rest, maybe 60 milliliters of water vapor per hour, very little.
Yeah.
Moderate exercise, that jumps to maybe 450 milliliter.
Okay.
But intense activity, like you said, 840 ml or even more per hour, that is a significant amount of liquid for fabric to handle.
It really is. So where does all that sweat go? Obviously, some just drips off, but a lot of it gets onto your clothes. And from there, some evaporates, which cools you down. But it also creates this sort of humid microclimate between your skin and the fabric. Too much moisture trapped there. That leads to overheating and feeling, damp.
And this brings us to two really important mechanisms, wetting and wicking. Wetting is just how the sweat first spreads into the fabric itself.
Okay, like soaking in.
Kind of, yeah. And then wicking is the fabric's ability to actively transport that sweat, pull it away from your skin towards the outer surface of the garment.
Ah, so it moves it outwards.
Precisely. Both wetting and wicking are critical for good moisture management.
Okay, so the fabric has to grab the sweat and then sort of shuttle it to the outside. Makes sense. So what specific fabric properties make this happen well?
Well, the research highlights a mix of things. The actual fibers used, the physical properties like thickness, and the way the fabric is constructed.
Let's start with fibers.
Yeah.
What materials usually dominate activewear and why those?
You see a lot of synthetic fibers, things like nylon, polyester, spandex. They're really preferred for active sportswear.
Why is that?
Primarily because they have really good wicking capabilities and excellent moisture transport. They're just very efficient at moving sweat.
Okay. And what about natural fibers like cotton? We all know cotton feels nice, but how does it fare with sweat?
Well, natural fibers tend to absorb more moisture, which can actually hinder the wicking process. We can get into the details a bit later, but generally that high absorption makes it harder for them to move moisture away compared to synthetics.
Got it. So synthetics generally move sweat better. We'll come back to the absorption aspect. What about the fabric structure, how it's put together?
Structure is definitely important. Knitted fabrics are super popular for activewear.
Right, they stretch well.
Exactly. They stretch, they resist wrinkles, they can offer a close fit, and crucially, they often have high air permeability.
Air permeability. That sounds like breathability.
Yeah.
how easily air passes through.
That's exactly it. It's how breathable the fabric is. And that airflow is vital. It helps carry moisture vapor away from your skin and helps the sweat evaporate off the fabric surface. That's the end goal for drying.
Okay, so breathable fabrics let the sweat evaporate more easily. Makes total sense. Now, the research we looked at mentions moisture management properties and something called a moisture management tester. What's that about?
Right, the MMT, or moisture management tester. Think of it as a tool for objectively measuring how a fabric deals with liquid sweat. It gives us hard data on its moisture handling skills.
Okay, and what kind of data does it provide?
It measures 6 main things, but basically, how fast the fabric gets wet, how quickly it absorbs moisture, how far and fast that moisture spreads across the fabric, and importantly, how well it moves moisture from the inside surface near your skin to the outside surface.
Okay.
All these measurements get combined into an overall moisture management capacity score, the OMMC. It's essentially an overall grade for the fabric's sweat handling ability.
OMMC. Like the final grade for moisture management. That's useful. The source also mentions surface texture, roughness, and friction. How does that fit in?
The texture affects how easily sweat can move across the fabric's surface. A rougher surface, more friction, can actually slow down that movement.
Interesting.
Whereas a smoother surface lets the moisture spread more easily towards the outer layer where it can evaporate.
So smoother might actually mean faster drying in some cases. And then the obvious ones. Fabric weight and thickness.
Yeah, those physical properties matter too, generally heavier and thicker fabrics. Well, they can hold more moisture and might restrict airflow a bit more, so they often take longer to dry.
Right, that makes intuitive sense.
Yeah.
Okay, so to really test all this, the researchers in our source material conducted a study. What was their main aim?
They really wanted to scientifically measure the drying performance of different knitted fabrics, the kind you actually find in activewear under various conditions, and see how those fabric properties we just discussed influenced drying.
And what fabrics did they test? Sounds like they covered the bases.
They did 9 different types. They had 100% natural cotton, some 100% synthetics like polyester and nylon, and then a whole range of blends.
Like cotton mixed with synthetics.
Exactly. Cotton viscose elastane, cotton polyester, wool polyester, and then various synthetic blends too, like polyester nylon elastane, polyester spandex. A real mix.
Okay, a good variety. And how do they measure the drying speed and these other properties?
They used several instruments. A dry rate tester measured, well, the drying rate. They used that moisture management tester, the MMT, to assess liquid handling. An air permeability tester measured breathability, and an automatic surface tester measured the roughness and friction.
Okay, a battery of tests. So, under standard lab conditions, what were the main findings? Which fabrics dried fastest?
The results were pretty clear-cut under those conditions. The fabrics with the highest dry rates were generally the pure synthetics or the synthetic blends.
And the natural ones.
The 100% cotton and the blends containing natural fibers tended to have lower dry rates, meaning they dried more slowly.
And that links back to the wicking thing we talked about. Synthetics are just better at moving the moisture.
Precisely. They pulled that moisture away from the inner surface more effectively, allowing it to evaporate faster from the outside.
Gotcha. Now, the source mentions a heat map analysis. Sounds visual.
Yeah.
What did that show about the relationships between fabric properties and drying?
Yeah, the heat map helps visualize correlations. It showed that thicker and heavier fabrics generally correlated with poorer drying performance.
Which makes sense. Traps moisture, less airflow.
Exactly. And conversely, higher air permeability, better breathability, generally led to better drying performance. And, as expected, the synthetic fabrics tended to have higher permeability.
What about the surface feel? Smooth versus rough.
That mattered too. Smoother surfaces, the ones with lower friction, tended to correlate with better drying. The idea is that sweat spreads more easily on a smoother surface.
Okay. And those detailed moisture management measurements from the MMT, how do they link to drying speed?
Several factors stood out. Lower wetting times, meaning the fabric got wet faster on both sides, were beneficial. Higher absorption on the outer surface, away from the skin, also helped drying.
So you want it to get wet fast, but absorb more on the outside.
Right. Pull through quickly. Also, a larger wetted radius and faster spreading speed, again on both surfaces, correlated with faster drying. And significantly, that overall moisture management capacity, the OMMC score, that showed a strong positive relationship. Better overall moisture managers dried faster.
Wow. Okay, so it's Quite complex how these factors interact. Now, they didn't just test under standard conditions, did they? They played around with sweat volume and airflow.
Right. This is where it gets really practical. They simulated different scenarios. Light sweat, heavy sweat, and also varied the airflow across the fabric, like still air versus a bit of a breeze.
And what happened when they changed those things?
Generally, for all fabrics, increasing the amount of sweat actually increased the drying rate, and increasing the airflow also improved drying performance.
Wait, more sweat made it dry faster. That seems counterintuitive.
It does initially, but think about the driving force. More moisture creates a greater difference between the fabric and the surrounding air, potentially driving evaporation more strongly, especially if there's airflow. And the effect of airflow was more pronounced when there was more sweat present.
Ah, okay, so they work together. More sweat provides more fuel for evaporation, and airflow helps carry it away.
Kind of, yeah. And they noted that fabrics with higher percentages of synthetic fibers showed a stronger increase in drying rate as sweat volume went up. Airflow helped everything, but the sweat volume seemed to have a slightly bigger impact overall.
Why would synthetics respond more strongly to increased sweat?
It probably goes back to their inherent wicking ability. They're designed to transport moisture, so when there's more moisture available, their transport system, let's say, can work more effectively. The researchers suggested that the combo of high air permeability, a smooth surface, and good moisture transmission properties in some fabrics explain this strong link between drying rate and both sweat volume and airflow.
So it's really the synergy of these properties. Okay, the study also developed a statistical model to pinpoint the most critical factors for predicting drying speed. What emerged from that?
Yeah, the regression model identified the statistically significant factors. The things that positively impacted drying rate, meaning they made fabrics dry faster, were higher air permeability, higher sweat volume, more airflow, and a better overall moisture management capacity, OMMC.
Okay, that aligns perfectly with what we've been discussing. What about factors that slow drying down?
The model found that a longer wetting time on the top surface, the one next to the skin, greater thickness, and higher frictional coefficient, meaning a rougher surface, all had a significant negative impact. They were associated with slower drying.
So, practically speaking, you want a fabric that gets wet quickly on the inside, isn't too thick or bulky, and feels smooth.
Exactly. And is breathable and good at managing moisture overall. The model confirms that airflow and even the amount you sweat can boost the drying process. It's also worth noting that some parameters, like fabric weight or specific roughness measures, didn't show up as independently significant in the final model.
Why not?
Likely because they're highly correlated with other factors already in the model, like thickness is closely related to weight, and frictional coefficient is related to roughness. And the individual MMT parameters are all wrapped up in that overall OMMC score.
Right, they don't add unique predictive power once the main factors are accounted for. And how good was this model at predicting drying performance?
It was pretty good, actually. The R-squared value was over 77%, which means the model could explain more than 3/4 of the variation in drying rates based on these factors.
Okay, so these findings, while detailed, seem to fit with the bigger picture of fabric science, right? They aren't completely revolutionary.
No, our source indicates they align well with previous research. For instance, the idea that cellulosic fibers like cotton absorb a lot of moisture, making liquid transport harder, is well established.
And the effectiveness of synthetics for wicking and helping body temperature regulation.
Absolutely. That's confirmed again here. Even though they absorb less water overall than naturals, their strength is in moving it.
What about weight and thickness?
The finding that heavier, thicker fabrics dry slower. That also supports previous work. They just hold more moisture and impede airflow.
And breathability. Air permeability.
Definitely reinforces its importance. You need that airflow for vapor transfer and faster drying.
And lastly, the surface smoothness.
Yes. The link between smoother surfaces, better moisture control, and faster drying is also consistent with earlier studies. Easier movement of moisture.
Okay, so we've really gone deep into the weeds, or maybe the fibers, of quick-drying sportswear. What are the main takeaways for you, the listener?
I think the key things are: 1, synthetic fabrics generally outperform natural ones for quick drying due to better wicking. 2, factors like how much you sweat and the airflow around you really do matter. And 3, specific fabric properties like breathability, air permeability, and overall moisture management, OMMC, are crucial indicators of drying performance.
Right, so the aha moment is realizing that understanding these technical bits, air permeability, OMMC, fiber type, actually empowers you to choose activewear that will genuinely keep you more comfortable. It's not just marketing fluff. There's real science dictating how that fabric feels when you're working out.
Precisely. And maybe a final thought to chew on. We've focused on sportswear, but where else could these principles apply? Think about bedding, right? Or maybe even industrial settings where controlling moisture on fabrics is important.
That's a great point. Like, how can we optimize fabrics for extreme heat or humidity,
Yeah.
going beyond just room temperature tests?
Exactly. What other environmental factors could be explored?
Lots to think about. And for you listening, maybe you reflect on your own gear. Do these scientific insights resonate with your experiences? Next time you grab workout clothes, maybe glance at the label, check the material blend. See if you notice a difference now that you know a bit more about the science behind staying dry. Thanks for joining us for this deep dive.